So if we cast a dice once, how many possibilities? There will be 6 possibilities, right? 1, 2, 3, 4, 5, 6. And suppose this dice is a good one. So what's the probability 1 will show up? 1, right? And what's the probability, 1, 6. Sorry, 1, 6. What's the probability 2 going to show up? 1, 6. So what's the expectation of x? The same thing, right? You want to remember this is a summation of x times px. Okay? So that would be 1 times 1, 6, 2 times 1, 6, plus 6 times 1, 6. What's the probability here? There will be 6 and 1 plus 2 plus 6. So what do you get? You get 3.5. As we just talked about before, if the expectation of x, in this case, we cast a coin twice, okay? Expectation of x is equal to 1. That means on average, if we do this kind of experiment, the number of heads will show up is 1 time, okay? If you cast a coin 2 times, on average, you will expect the heads will be there 1 time, okay? But the interpretation here will be a little bit more difficult because the dice has only 1, 2, 3, 4, 5, 6. Will this number show up? No, it will never show up because it doesn't have 3.5. So the interpretation really depends on the situation, okay? So now let us get to variance, okay, variance. Of course, we want to know what's the definition of variance. The same thing, when we talk about numbers, right, we have n numbers, so we consider that each number has the same probability to show up, so we use 1 over n. But now, we are talking about probability distribution. Each number has a different probability to show up. So we use the probability as a weight. So in this case, what is variance x? Okay, we put down variance x. Okay, what is that? That would be expectation of x minus mu x squared. Okay, what does this mean? I will erase this, okay? In terms of formula, that is summation x minus mu x squared times px, okay? Certainly, if we're gonna be more careful, that will be I is equal to 1 to n xi minus mu x squared pxi. As you know, when we talk about the numbers, okay, when we have m numbers, we can simplify the formula of variance. And the same thing here. We can find a way to simplify the formula here. So let us do it now. Okay, this will be summation I is equal to 1 to n, and this will be xi squared minus 2xi mu x and plus mu x squared times pxi. Any questions so far? Any questions so far? Okay, so we want to get the whole thing out, okay? So what is that? That will be equal to summation I is equal to 1, okay, n and xi squared times pxi minus 2 summation I is equal to 1 over n xi mu x times pxi. Okay? And then plus summation I is equal to 1 over n mu x squared times pxi. Any questions so far? We simply expand this formula, okay? We expand it, okay? And to simplify it to this way. Any questions? Okay. So this is still the same thing here. What can we do here? Because mu x, okay, mu x is a constant, okay, mu x is a constant. Okay, mu x is a constant. Mu x squared is also a constant, okay, because when you calculate mean, it is a set number, it's a given number, okay, it's a constant. So is it related to I? If I changes, will mu x change? No, okay, so because of that, we can get this out, okay? The same thing here, because mu x, okay, mu x is a constant. You already know what's the number, okay, it's a mean. So you can factor this out, you can move it out, okay? So now, minus 2, mu x summation I is equal to, from 1 to n, xi pxi. And then, plus mu x squared times summation I is equal to n, from 1 to n, and pxi. Okay, can anyone tell me what is this? Can anyone tell me what is this? It should be familiar to you. We just discussed it. We just talked about it. What is this? This is expectation, right? This is expectation. So let us continue. Summation xi squared pxi, okay? I just don't want to get too tedious. I forget about this part, okay? And then minus 2 mu x times mu x, right? What about this part? Can anyone tell me how much is this part? How much is this part? Still remember? We say for any probability, it should be less than or equal to 1 and greater than or equal to 0, right? And what about the whole thing? It should be equal to 1, okay? So that would be plus mu x squared. So then we know the variance of x, okay, variance of x, the formula is like this, okay? You can do it this way, but also you can do it this way. Summation xi squared times pxi minus mu x squared. Okay, because this will be 2 mu x squared plus 1 mu x squared. So this is what you get. Okay? Any questions? Okay, so now we want to calculate variance of x for this case. Okay, variance of x is equal to expectation of x minus mu x squared, also equal to summation x minus mu x squared times px. We already know what is the mean. Mu x is equal to 1, right? We have just done it. Mu x is equal to 1. Remember, we say expectation of x is equal to 1, right? So The first one is 2, okay? The first one is equal to 2. So 2 minus 1 squared times 1/4, right? And then the second x is equal to 1. 1 minus 1 squared times 1/2, and plus 0 minus 1 squared times 1/4. So what do you get? This one is equal to 0. This one is equal to 1/4. And that one is equal to 1/4. So that is equal to 1/2. Okay? So the variance is, the expectation is equal to 1. The variance is equal to 1/2. Okay? Now let's get to the second one, the second example. Okay, the second example, we cast a dice, right? Remember, we cast a dice. And expectation is equal to 3.5, right? The same thing, we want to know, so expectation of x, then variance of x. Okay? The first one is equal to 1, right? Still, let us just put down all the formula. Try to get familiar with those. It will be expectation x minus mu x squared, right? And what is this? Summation x minus mu x squared times px. It also equal to what? Summation xi squared times pxi minus mu x squared, right? Okay? So in this case, this will be 1 squared plus 2 squared plus 3 squared plus 4 squared 5 squared 6 squared times 1 6 minus 1 3.5 squared. Okay? So basically, if you know the formula, you should be able to do it. So in this case, I won't do that for you. Okay? So you've got a calculator, you should be able to figure that out. So any questions so far? Any questions? So today we cover random variable, right? And also the this is discrete type. Okay, this is discrete type. And also the expectation and the variance. Any more questions? Now we will get to the book. So please get your book out. Have you got a book? Okay, so turn to page 6. Turn to page 6. So page 6 talk about descriptive statistics, right? So what is descriptive statistics? Generally, you are here to learn the methods to organize, to summarize, to present data in an informative way, right? Of course, after we learn all this, the final point is that we want to infer from the sample to the population, right? So if you look at page 7, really what we want to learn is inferential statistics, the methods used to determine something about a population, right? Based on a sample, okay, based on a sample. And what's the population? That's the collection of all the possible individuals or objects or measurements of interest. So if you are interested in the student of the school, then the population will be all of the students in the school. And sample is just a portion of it, okay? And we talk about it, say, in terms of variables, there are two types. One is continuous, one is discrete. Look at page 9, okay, page 9. And then also we talk about the levels of measurement. So what kind of data we are dealing with? We are dealing with nominal data, okay, and ordinal data, and interval data, and ratio data. If you turn to page 12, okay, page 12, at the bottom there is a chart, right? So summary of the characteristics for all the measurements that we are interested in. So in this case, you can see very clearly what is going on there, okay? Okay, and also there are computer applications. So if you have some more time, you want to try your best to do some of them to get more ideas about what's going on. And also the computer applications, of course. So this book, in terms of clarity, okay, clarity, it's very clear, okay, very clear, talking about the data, what's the difference, like table 12, okay, that's a really good one. Any questions? Okay, let us get to chapter 2. Chapter 2, page 22. So we talk about frequency, right? And also relative frequency, okay? Relative frequency and frequency. And of course, when we talk about frequency distribution in certain way, it is also a probability distribution, as we just talked about here. The number of students, senior, male or female, right? And that's frequency. How many numbers? 2,000, 1,500. And then we want to turn that into relative frequency. And relative frequency is basically a probability, okay? And so at page 22, you know what's the frequency distribution. And on page 23, you have a table, right? And that's an example. You can practice it on your own. And you can put them into groups, right? So we have group data. You can put them into groups. And of course, in terms of expectation, mean, etc., group data has a different way, to calculate it from the, individual numbers that we have. But generally, it's not that difficult, okay? The formula will be here. We will talk about it very soon, okay? And then you look at page 25. Step 4, right? So in this case, this example tells you how to organize your data, right? You have so many numbers, okay? And it's confused. So you are learning a way to get them organized. So tally. If you look at step 4, right? Tally. Tally means count, okay? Tally means count. So how to count them? As I told you before, we use this kind of word to count it, right? But they use this. American use this. The same thing. Here is 5, and here is also 5. Okay? Okay. 26. Okay, page 26. Because it is a group data, right? It's a group data. So you need to know how to divide them into groups, okay? So you can just look at the example, especially with software, right? In this case, it is Excel. So if you have time, you should practice it, okay? Use your computer. Okay, page 28. What we really care about is probability, and that is relative frequency, right? Relative frequency. So after you get a frequency, that's how many times it happens. Then we want to know, relatively speaking, to the whole thing, how many times it happens. So that's in terms of percentage, okay, percentage. Any questions? And there's another kind of diagrams probably you haven't seen before. Look at page 31. It is called stem and leaf, okay, stem and leaf diagram. So this is like a sort of like a tree, okay, sort of like a tree, or maybe leaves, okay. Anyway, I'm not good at drawing diagrams. So if you look at it, okay, you look at page 31. It is sort of like a leaf and stem, right? So, or maybe like a tree, okay, maybe like a tree. But basically you have 8, okay. The left-hand column, okay, there's 8, and then the right-hand column you got 8 and 9. So what does that mean? There's one data 88 and one data 89, or one number 88, one number 89. Okay. Any questions? Page 35, to construct a histogram. As I told you before, because you have computers to help you do all these things, so we don't want to get into details. So here you can get some ideas about histogram. Okay, turn to page 40. You have cumulative distribution, and decumulative distribution. So we talked about this before, right? We talked about this before. So there are all sorts of charts and diagrams like page 42, page 43. You can do some exercise on your own, okay? And then page 46, that's called bar chart, okay, bar chart. And then page 48, that's called pie chart. And there are many examples here, right? There are exercises, okay? Page 53, there are exercises. You just try to pick out 1 or 2 and see if you can do it. It should be easy. Okay? Now let's get to chapter 3. That's describing the data, okay? So in this case, we are talking about central tendency. Central tendency, we have mean, right? Mean, median, right? Mean, median, and mode, okay, and mode. And also for mean, we have trim mean, okay? Some of the data, they may be too big or too small, so we cut them, okay? We trimmed it, okay? That's trim mean. And also we have arithmetic mean and geometric mean, right? So measure of tendency. And of course, we talk about the difference between population and sample, right? Okay, so if you look at page 66, population mean, we use mu, okay, mu as the symbol. And if it is X bar, that would be sample, right? Page 67, okay, page 67. Okay, and also all the probability, properties of arithmetic mean. And then get to 71, page 71. Median, right? What means median? That is the middle number, right? Median is the middle number. So 50% of the data is below median and 50% of the data is above median. But if you want to know median, you have to sort. You have to sort the data, right? You have to sort it from high to low or from low to high, okay? Find the middle one. If the number is even, okay, you get into trouble. If the number is odd, you just find the middle one, right? If the number is, let us say 500, okay, you have 500 numbers, or let us say, smaller number, 100 number. Which one is the median? Is the 50th one and the 51st one, add them together and divide it by 2. So the median, if there are 100 number, you get the 50th one and 51st one, get them together and divide it by 2, okay? So median, we are done. And then the last one is mode, right? Mode. And page 77, you get geometric mean, okay? Geometric mean. And also in one example, we talk about not the growth rate, but the rate of return, okay? The rate of return. How to calculate the rate of return? If you look at page 78, that is exactly the way to do it, okay? And then it talk about group data. We just forget about that part, okay? And then you get to page 88. Page 88. So we say there are distributions like skew to the right, okay, and skew to the left, right? And what's the relationship between mode, median, and mean in each case, right? We talked about this before. Page 88, okay, page 88. You look at if it is skewed to the right, okay, if it is skewed to the right, then mode is less than median and is less than mean, okay? And if it is skewed to the left, that would be the other way around, okay? Okay, in this case, you want to do some exercises here because mean, okay, there's a formula for mean. You want to know how to use that formula, okay? So now we get to chapter 4, page 100. This is about dispersion, right? So how widespread is the data, okay? How widespread is the data? So we have range, right? Also we have quartile range. Quartile range, okay? And then we talk about mean deviation, right? Mean deviation. So you need to have absolute value, okay? You need to have absolute value so that you measure the distance of each point, how far away is each point from the mean, okay? And of course you're going to get to variance, okay? Page 104, variance, okay? We also talk about today the variance of a random variable, okay? And also, you know, there's a difference between population and sample. So if you look at page 104, that is for population. And if you look at page 106, that is for sample, okay, for sample. Okay, any questions so far? So far, so good. Okay. And of course, we talk about, you know, two types of data, okay, two types of data. And you want to know what's the difference between those data. Which one is more dispersed than the other? Then we have to get to coefficient of variation. That is 115. Turn to page 115. 115, it talks about, if you want to know the difference between two types of data or distribution, then you can use this coefficient of variation. And skewness, that is 117, because in this class we don't want to talk about all this, so you can forget about this part, okay? You can forget about this part. Of course, there are other measures of dispersion, okay? But, you know, in this case, you don't have to worry about it, okay? You don't have to worry about it. So, basically, we have done chapter 1 to chapter 4 is all done, right? You have to do some exercise there, and then get to the probability concept. That's the last part. We just finished 2 hours ago, right? Probability, okay? And we talk about experiment, we talk about outcomes, event, sample space, okay? Turn to page 153. 153 talk about some background stories, okay? What's classical probability and what's mutually exclusive, collectively exhaustive, all these ideas. Basically, what we use is on page 155. We use empirical concept, right? Empirical concept, and that's relative frequency, okay? We use relative frequency. So, turn to page 158. That's rules of addition, right? So let us say we are interested in, let us say the experiment is cast a dice once, okay? Cast a dice once. What's the probability? I mean, how many outcomes there? It will be 1, 2, 3, 4, 5, 6, right? And we are interested, what's the probability 1 or 2 will happen? So what does this mean? What would be the probability? It is probability 1, okay, x is equal to 1, or x is equal to 2. And how to get this number? So that would be the probability of x is equal to 1 is 1/6, right? And the probability of x is equal to 2 is equal to 1/6. So the probability of 1 or 2 going to happen, it is 1/6 plus 1/6, and that's equal to 1/3, right? Do you follow me? Yes? No. Okay, so I should put that down. Okay, thank you for your feedback. So, cast a dice once. Okay, we have 6 possibilities. 1, 2, 3, 4, 5, 6. And now I say I'm interested in Px is equal to 1 or Px is equal to 2, right? If I say P is equal to 1, that would be very simple, just 1/6. The same thing, Px is equal to 2, that would be equal to 1/6, right? And you know, these two has no intersection, right? And if I say I'm interested in this happen or this happen, okay, so that is P, let us say this is A, right, and this is B. A or B, that would be A union B, right? And so that would be 1/6 plus 1/6, so that would be 1/3. But as you may know, when you put down this, okay, P of A union B is, as a matter of fact, PA plus PB and minus A, probability A intersect B. But A intersect B is equal to empty set. Okay, it is an empty set. So then this will be 0, right? 1/6 plus 1/6 minus 0 is still 1/3. Okay? So you get it? Okay, good. So, yes, smile is good. So let us get to 159. 159, you have complement rule, okay? This is called A, right? And this symbol called, this is not A, okay? Not A. So A union not A should be equal to what? The sample space, right? Because if we draw a diagram, The whole thing is A, right? What about not A? It is outside this circle, right? These are not A. So A or not A will be equal to the sample space, okay? But we haven't discussed too much about it, so the same thing. You don't have to worry about it, but you do need to know this, okay? You do need to know this. And also P, A, union B, union C, okay? You need to know this formula, okay? You need to know these two, but you don't have to worry about this kind of complement rule. What about joint probability, okay? 161, page 161. Joint probability means that means joint probability. We are interested in intersection. A happen and also B happens. Okay, this is called joint probability. Joint probability Okay, so if you look at page 161, formula 5-4, if you look at that, at the bottom, right? Formula there, okay? And there are many exercises here. 163, okay? Try your best, do some of them. If you can, do all of them. 164, it talks about multiplication rule. Since in this class we haven't really talked about it, so you can forget about this part, okay? But let us say 5-5, okay? Formula 5-5 is set. If this is the case, okay, if this is the case, if this is true, okay, if this is true, then what's the relationship between A and B? They are, if this is true, then what's the relationship between A and B? They are independent. And also they are not mutually exclusive. That means A intersect B is not equal to empty set, right? Okay? Okay. If you look at page 166, this is conditional probability, right? This is conditional probability. And so there are rules there, formulas there, and you want to get to those. Okay? So basically, if you look at table 5-1, that's on page 167. If you look at table 5-1, that is exactly the same table I put on the board before, right? It is just that they have more items, okay? Basically, this is one good example that you can learn conditional probability, okay? Conditional probability. Okay. And then they talk about, Bayes' theorem, okay? Bayes' theorem, that's on page 171. Page 171, Bayes' theorem. So the same thing, right? They put down a formula again and tell you the idea. And then on page 171, you get the difference between two types of probability. One is prior probability, okay? And the other one is posterior probability, okay? You look at the middle part of the book, that's prior probability. And then conditional probability is actually posterior probability. You get more information, okay? You get more information. Okay. And page 175 is about formula and how to count it. Actually, you don't need to worry about it, okay? You don't need to worry about it. So I think that's about for today. But if you look at chapter 6, we already started the discussion of chapter 6, right? And actually, we already finished almost 50% of chapter 6. So the first midterm will be from chapter 1 to chapter 6. So starting next week, we will discuss some more problem sets